In our boron activity, we noticed that there were two different types of atoms. And an atom in boron could either have 5 neutrons or 6 neutrons, but it definitely always has 5 protons. So we know that it's boron because it has 5 protons. That will never change. An atom of an element always has a unique number of protons, but the number of neutrons can vary in an atom, and it still maintains its identity. So in this example, boron has 5 neutrons and is still boron, and it has 6 neutrons and it's still boron. The one thing that is consistent is that it always has 5 protons. And when we're talking about those scenarios, we are discussing something that are called isotopes. Move on to the next slide. So an atom of an element can have different numbers of neutrons or electrons. We'll talk about electrons much later on, but we're going to just focus on neutrons. And it could still be that same type of atom. Atoms of an element that have different numbers of neutrons are called isotopes. So in the case of the boron, we had 2 different types of boron, one with 5 neutrons, one with 6, and so for that reason, boron has isotopes. Atoms of the same element that have different number of electrons we call ions. Don't worry about that now, but just a heads up, we can also have different electrons. So let me give you an example of how we write an isotope. Atoms of the same element, remember, always have the same number of protons, but we notice that their atomic masses or mass tend to come often in decimals. And that's because of the different types of isotopes. When we want to focus on just one atom, one single atom of all of the atoms there are, we create what we call a nuclear symbol. And the nuclear symbol will have the mass written in the top left-hand corner and the atomic mass written in the bottom left-hand corner, along with the chemical symbol. And then we give it a hyphenated notation that is called, where we write the name of the chemical with a dash and then the mass number. So let's go through a few examples. Here I have a carbon. I am told that this carbon atom has 6 protons, 6 neutrons, and 6 electrons. So let's talk a little bit about charge also. Remember, 6 protons means you have 6 positive charges. With 6 neutrons, remember neutrons have no charge. And 6 electrons have 6 negative charges. The overall charge is 0. This is going to become more important later on, but for right now, we'll go ahead and start that. With our isotope symbol, remember we were saying from the slide above, the mass goes in the top right-hand corner, and the atomic number, or the number of protons, goes on the bottom left-hand corner. So carbon has 6 protons. I place the 6 on the bottom left-hand corner. And then I want to do the atomic mass. So the atomic mass, remember, is my protons plus my neutrons, and 6 AMU from the protons plus 6 AMU of the neutrons equals 12 AMU. That's the number I place right over here. In the future, in the top right-hand corner, I'm going to put the charge. Since there is 0 charge right here, I'm going to leave it blank. This here now has a name. I give it the chemical name, carbon. Then I place a dash, and then I write the atomic mass, carbon 12. Let's try a different type of carbon that exists. Here we have a carbon, in which case we have 6 protons, 7 neutrons, 6 electrons. Let's do the overall charge. We know that protons have a +6 charge, neutrons have a 0 charge, electrons have a -6 charge. our overall charge is 0. So again, as you remember, atomic number is on the bottom left-hand corner, atomic mass on the top left hand corner. So we have 6, but now I have 6 protons and 7 neutrons, in which case 6 AMU plus 7 AMU equals 13. All right, so I place the number 13 on the top left-hand corner. Since I don't have a charge, I leave this blank. This here is now called carbon 13. Let's do a couple more. We'll whiz through these here. I have 6 positives, 0 charge for the neutrons, 6 negatives. It still has a 0 charge. All right. I know I have 6 protons. I put that on the bottom. And now in this case, 6 plus 8 equals 14 AMU. That is going to be 14 here. And this here is carbon 14. I hope that some of you have heard of carbon 14 because it is a great way for us to find the age of different prehistoric things that have died many, many years ago. Let's try chlorine. For this chlorine, we're going to add a little bit more to it. This chlorine has 17 protons. That means it has 17 positive charges. Remember, neutrons have 0 charge. And this one has 18 negative charges. So in this case, because it has 18 electrons, they didn't equal the number of protons, and this happens sometimes. This has an overall charge of a -1. So remember, on the bottom, I place the number of protons, bottom left. So that's 17 protons. On the top corner here, I'm going to calculate the atomic mass. So that's 17 AMU plus 19 AMU. And that works out to be 36. Is that correct? Yes. 36 on top. And then I place the charge on the top right-hand corner. I'll just write a minus, not -1. And this here is called chlorine 36. Okay, let's try this one. I'm going to have you stop the video and try this one by yourself and see what you come up with. Is this what you came up with? All right. So we'll talk in class about how certain isotopes are radioactive, but I'd like you to practice some of the problems that you have in your flip teach.